talk about fission and radioactivity. Fission is when a bigger nucleus splits up into two smaller ones. And radioactivity is when a radioactive nucleus emits spontaneously some particles like alpha, beta and gamma rays. Inside an atom there is a nucleus which contains protons and neutrons, and number of protons will determine the nature of the element. Except hydrogen, there are neutrons inside the nucleus along with the protons. So inside the nucleus there are protons. These protons are positively charged. Because of the positive Coulomb repulsion between them, this nucleus would be explode into several parts. But there is a strong nuclear force which is responsible to hold the nucleus. This is 100 times stronger than the Coulomb repulsion, and because of the strong nuclear force, this nucleus stays as it is. Now, how many neutrons can there be inside a nucleus in order to have a stable configuration of the nucleus? We need to find out the number of neutrons. This is the stability curve. Number of neutrons is along y-axis, number of protons is along z-axis. And this is a stability line. This corresponds to n equal to z. As we go higher and higher, we can see that this red line, which is a symbol of the number of neutrons, this deviates from this straight line value. That means n exceeds the value of z. Number of neutrons becomes greater than the number of protons. For example, if we have z equal to 80, that is number of protons equal to 80, then we must have neutron number equal to 110 in order to have a stable nucleus. In this side of this graph, number of neutrons is greater. In this side of the graph, the number of proton is greater. In this side, at this portion of this plot, this corresponds to a higher A value, that is total number of neutrons plus proton is higher. For example, if we have the most stable nucleus, which is iron, where Z equal to 26. Here the number of neutron is iron is 56 and 26. So 56 minus 26 equal to 30. 30 is the number of neutrons here. So now we need to find out the number of neutrons and what is the type of the radioactivity in which the alpha, beta and gamma ray emission occurs. Three types of stuffs will come out as a result of radioactivity. One is alpha, which is a helium. It contains 2 protons and 2 neutrons. Other is beta, which is a negatively charged electron. And this one is the gamma ray, which is a portion of the electromagnetic spectrum. Now, alpha is a kind of particle which will be emitted from heavier atoms. Heavier in the sense they are having 82 or more number of protons inside the nucleus. And when an alpha particle is emitted, as an alpha contains, it's a helium 1, so it contains 2 protons, 2 neutrons, that is Z equal to 2 and A equal to 4. So if an alpha gets emitted, this is from a helium nucleus, then we get thorium, which contains 90 protons, and total number of nucleon is 234 because 4 is out because of helium is having A equal to 4, and we have a alpha particle. And for beta, which is the negatively charged electrons, beta particles are emitted from nucleus which have too many neutrons, and here one of the 4 fundamental interaction is involved, which is the weak interaction. Suppose this is rhenium. When a beta, that is an electron, emits from the rhenium, as one negative charge is reduced, so one positive charge is increased, So it is now the osmium nucleus having 76 number of plus charges, that is 76 number of protons. This is a weak interaction, and in this process neutrons are converted into protons, antineutrino, and an electron. There are other beta emission, which is a beta plus, which is the antimatter electron, which is this is a plus charge electron kind of thing. And for the beta plus emission, this is again a weak interaction, and in this case protons are converted into neutron, neutrino, and beta plus, that is positive electrons. And high energy electromagnetic rays emitted as gamma rays from the nucleus when the nucleus is extremely excited, that is it has extremely high energy state it is in. In case of radioactivity, some things must be conserved, which is energy must be conserved, momentum must be conserved, charge must be conserved, nuclear number must be conserved, but mass will not conserved, as there is a reduction of mass which is transferred as energy, because we know E equal to mc square.